I'm Anil Kumar, and some of our students are now learning natural logarithm, right? That is to the base e. So this question is basically to understand what is a natural log and how we can sketch its graph. Question here is, sketch the graph of f of x equals to ln x minus 1. Clearly label at least 2 points on the graph and include important features such as scale, axis, asymptotes and intercepts. Now that is a common thing. Whenever you do any graph, you should actually, especially the logarithmic graphs, asymptotes, intercepts are very important, right? Okay, so this is just a reminder. When we say ln, right? So let me first sketch ln x. So this means base is e, right? Now what is e? As you know, e is a number which is, let me show you on the calculator also, 2.718, but you can find this number like you can just press e to the power of 1 equals to, right? So you get so many digits. So 2.178 or 2.718 is good to remember, 718. Okay, so that is the value of e which we are going to use for this particular sketch. Now first I will sketch the graph of ln x, and that means 1 unit to the right, and then what we will do here is we will do ln x and then we will do horizontally translate. So horizontally translate 1 unit right. Is it okay? That is what we will do. To sketch the graph, good points to consider are these. First and foremost, I will always consider vertical asymptote. So let me write vertical asymptote. For we cannot have 0, and that x equals to 0 gives us vertical asymptote. So that is first thing. So in this particular case, or for that, any parent logarithmic function, vertical asymptote will be at x equals to 0, and that gives us the domain of the function. It has to be positive, right? Greater than 0. Now we will write down few values of x and then find ln x. We can use calculator also, so that gives you vertical asymptote, right? Okay, it is not defined at x equals 0, so that value is not defined. Okay. Now when we have base as e, then good points to check will be, for any graph on logarithms, one will be, ln 1. ln 1 is always 0, correct? Then we can take ln e, right? When you have these things same, you should get e, right? And then we can have ln 1 over e, or e to the power of minus 1. So that will give you minus 1 as your answer, correct? So these are good points to check, right? And of course, we can have ln e square, which will give us 2, right? I'm sorry, this is 1, right? This is e to the power of 1, I'm sorry. So these are your y values, correct? Now e, as you know, is 2.718. So first point we get is what is the x-intercept? So this is your x-intercept. Let me write down in red ink. So this is x-intercept when the y value is 0, and that happens for logarithmic graphs at 1, right? Now we know ln e is 1. E is 2 point, so we'll write e as 2.718. So it is close to 3, right? So close to 3, it is 1. So I'm just showing it here. Is it okay? So that is 1. E square is 2.718 square. So let me square this number, or let me write this as e square. let me retype it. So e, and we'll write 2, e square is 7.38. So 7.38 is close to 7, and the value is 2. So that is the next point. Now 1 over e is 1 divided by 2, so around 0.5, but less than that. So that will give me minus 1. Do you see that? So that is my another point. As we go closer, we know the graph should be approaching negative infinity. Let me use a light color to sketch this graph. So it's very, very close to your y-axis, and this graph which we have drawn here is basically ln e. Now we have to draw, ln x, I'm sorry, ln x, okay. that is to the base e. Now we need to shift it 1 unit to the right. So if I shift this 1 unit to the right, what happens? First is the y-intercept itself. I mean the y-axis itself, which is the vertical asymptote, will now be at 1. Is it okay? Then each and every point shifts 1 unit to the right. So this comes here, this comes there, that goes here. Do you see that? That goes here. And accordingly, I have my final graph. And this graph should be very, very close to this, but 1 unit to the right. Do you see that? And that is your vertical asymptote. So it goes like this. Vertical asymptote is kind of like this. And this point 1 will now be here. Do you see that? So this one shifts here. So move it 1 unit to the right to get your final graph, and this is your graph ln x minus 1, right? So translate ln x 1 unit to the right to get the needful, right? So in this, these are our critical values. These are 4 different values shown on the graph, and then 5th one is the vertical asymptote. I hope that helps you to understand the concept. So these are the final points, okay? These are the final points which we have. Thank you and all the best.